Welcome to mechanical tutorial. I am going to teach you different techniques in SolidWorks for mechanical engineers. I am going to train you different modules like surface modeling, sheet metal and enclosure design, product design, plastic components design, reverse engineering and many more tips and tricks in SolidWorks. Hi, today I am going to explain about sheet metal brackets. Here I am going to create a 3D model as well as 2D drawing. So this is the 2D drawing and this is the drawing for flat pattern. So this PDF I am going to upload, so you can check in the description. So this is the model. So here I am going to explain about base flange, edge flange, cut extrude, hole features. So this is the drawing. So let's start now. So I have taken the new SolidWorks part file. Select the top plane. Select sketch. Select center point rectangle. $60, 30. Now go to sheet metal, base flange. So here I am going to take 2 mm and K factor is 0.45. So K factor should be always less than the 0.5. Now go to sheet metal module, select edge flange, select this edge and simply drag it down and say OK. Now go to sketch and edit. Keep it in front view. Select this point, drag little bit down and draw a line from here. And draw an inclined line. Now select trim tool, power trim, and trim all these additional lines. Now this is 5 mm. The distance between this edge and this line is 10 mm. This is 45. This is 45. Distance between this line and this edge is 65. So the sketch is fully constrained. Now say OK. See here. One thing we need to verify that this one should be material inside. So when I check from the top view, so it should be exactly inside. So right side view, if you can see, so the bend is formed inside this edge. That is important. Now similarly, create one more flange. Select this.
select this edge flange and select this edge. Simply say OK. Now we have to edit this sketch. So before that we have to show all these entities and we have to show the sketch. So this sketch is visible. So we have to show this sketch also, because since these two flanges are symmetric, so we can straight away convert these entities. So select convert entity, select this edge, complete outer boundary of the flange and say OK. Now trim this, select corner trim, select these two lines. So this loop is closed. Now say OK. See here. Now we can hide these sketches. See this. Now these two sketches are symmetric. So whenever we modify this sketch, automatically it updates to the other flange at a time. So this is a parametric relation. Now we have to create two more flanges. So select this edge, drag outward, and this edge, drag outward. So we have to dimension this. It is 18 from this edge. So simply we have to give the dimensions. So this is also 18. It is created now. So now I am going to create this slot on the top face. So select this face. We have to go to cut extrude and we have to select the straight slot. So simply place it here. Now the distance from this edge to this point is 20 and this is 25. And this is 8. Save OK. So link to thickness. See here. Now I am going to create the side hole, this 10 mm. So select this face, go to sheet metal, select simple hole and say OK. So this is 40, dia is 10 mm, distance between this edge and center point is 40. Here, since hole is in two flanges, so we can instead of blind, we have to select through all. So here, it is created both the sides. Now I am going to create 6 mm hole. Select this face, go to sketch. So since it is in a hole, should not select sketch, we have to select simple hole. So say OK. Now draw one more circle. Make it vertical. Select these two circles once again, make it equal. The distance between these two circles is 30. And the distance between this origin and this point is 10. It's not origin, we have to select from this edge. And this line is 10 mm. This edge and the center line is 12.5. Draw center line, select mirror entities. And save. So all the holes are created at once. So we have to modify the hole diameter. So hole diameter is 6 mm. See here, we have to update this. So it is modified. So the simple bracket is created now. Now I am going to show how to create this drawing. So select model view. Here I have taken 1:1. So we have to set here 1:1. Go to annotation, select smart dimensions, place this hole dimension. So since we have two holes, we have to type 2 into x. Select this edge and this point. This is 45. And this edge and this point. This is 45. So this is 65. So we have to mention the hole position. This is 40. This is 40. This gap is 5 mm. This is 10 mm. So we can place in right direction, right side, and move a little bit inside. So the hole location, since we have two holes and these two cutouts, we have two cutouts in the two flanges. So we have to mention as 2 into. We have to place the top view as well as right side view. Go to annotation. This is 66. Overall height is 65. This value is 30. This is 10. So we have to mention both the sides. This is very much important. This is 12.5. We can flip the arrows inside. So we have to place the hole diameter. So these two dimensions are for two holes. So we have to mention 2 into x. See here also, these are for two holes, two parallel holes. So we have to mention 2 into x. The 6 mm diameter is 4 holes. So 4 into x. We can move it outside. So we have to rearrange the dimensions properly. That is very much important. So we have to mention this edge to edge. So here we have already mentioned the 66 dimension. So we have to keep this as a reference. So select this bracket. So this is a reference dimension. 25, so the center to this edge is 15, this is 8, this is 20, so this is 4, and we can show the note instead of providing all the dimensions. We can show note as slot 33 by 8. So you can show like this. Instead of providing these dimensions, slot dimensions, you can simply mention this here. So we can eliminate these dimensions, these highlighted dimensions, like radius, width, and these 3 dimensions. Simply we can write slot 33 by 8. So the distance from this edge to this edge is 20. We have to mention both the sides. So we have to place the isometric view in shaded form for better visibility. And after placing all the dimensions, we have to show the center marks. So center marks, we have to select this option, select this circles. We have to, so placing center marks in the last is the best practice. So this is the drawing in folded state. Now I am going to explain how to show dimensions in Flat Pttern. So go to model view, select this model. Here also we have to place isometric view, shaded form. So when it goes to manufacturers, you can visualize the model. So right click and we have to go to properties. Flat Pttern, it is not a flattened form. So we have to go to model, hide all types. Now we have to go to configurations, Flat Pttern, and go to sheet metal, click on the flatten. Now it is in flattened form. Check the default. So it is flattened. Now we have to go to annotation, select horizontal ordinate, select this point and keep on placing all the dimensions. So since it is a simple component, we can place ordinate in one direction. So all the dimensions are covered here. Now go to vertical ordinate, select this point, place it here. So hole locations are very much important. Here we can select the midpoint. Now we have to see each and every dimension. So this is repeated. See, this is for 4 holes. 4 into x. This dimension is for 2 holes. This is 2 into x. So we have to move near to this component so that it's easy to read these dimensions. So this is the drawing in folder sheet and this is in Flat Pttern. So this is brief about a sheet metal bracket of 3D modeling and 2D drawing in SolidWorks. Thanks for watching.